All right, it's time to start looking at equations in standard form because that's really the way you're going to see a lot of this stuff, the standard form. You're going to see it mostly in standard form. Very, very seldomly is it going to be in vertex form. Almost never. They always give you an industry and most math books, and you know that from Math 10C where we had to take something like this and factor it last year. So we never looked at anything in vertex form. Vertex form is a real convenience for us though, because of course vertex gives you max and min, axis of symmetry, and all those other wonderful things. Okay, so well, let's deal with what we got. Standard form, remember, is y equals to ax squared plus bx plus c. That's this guy right over here. And we did touch on this in a previous podcast, but I want to show it to you again. How do you convert this guy into standard form? Well, remember this guy. BADMAS, everybody's favorite, right? Brackets, exponents first, then multiplication, division, and addition and subtraction. So if you look at this guy, what we have here is 2 times x minus 1, but that's x minus 1 squared, because if it's not squared, it's not a quadratic, right? Minus 5. You got to do the FOIL thing first, right? That gives you your x squared. There's your minus x and minus x. So I'm going to do 2 steps in one and just add them together in my head to find it to be minus 2x. Ooh, that's really hard. And minus 1 times minus 1, of course, is plus 1. Now here's where people make the mistake. They forget that that 2 is on the outside of a bracket, which means, yep, distribution, here it is, 2x squared minus 4x plus 2. Now you can finally do the addition subtraction at the end of all of this. Minus 5 and 2 gives you a 2x squared minus 4x minus 3. And that's what this equation looks like in standard form. Now, the cool thing about this, though, is again, like I mentioned in the previous podcast, look how this 2 never changed. It's the same a value that was out here. But now look at this. Where's the x? Where's the q? Where's the p? Where are these things? Remember, PQ was our vertex, and P in this case was 1 and minus 5. We knew what the vertex was. Look over here, no more vertex. Okay, so what does this mean? Well, you're going to find something very, very interesting come about here, and that's based on this guy right here, and we'll talk about that in upcoming podcasts.